Good morning. My name is Simran again. So today we'll be going through Pythagoras theorem together. So Pythagoras theorem is one area in mathematics where students they lose hope in maths. So today we'll be trying to make this simpler for you to understand. So as you can see on the screen, this is the formula which is used for Pythagoras theorem. So we have a squared plus b squared which is equals to c squared. So we'll try to figure out what this is about. So first of all, what is the Pythagorean theorem? So it only applies to right angle triangles. That's the first thing you have to know. Like we know there's various other types of triangles that we have. It could be a scalene triangle, we have isosceles triangle, we have equilateral. But when it comes to Pythagoras theorem, it is only applicable if it is a right angle triangle. So that's that kind. So if it has a 90-degree angle in it, then you can apply Pythagoras theorem to it. The next rule that it is going to have is the hypotenuse is always the longest side. So if you have a triangle, let's say that's A, B, and C, the C, which will be the longest side, that would be labeled as the hypotenuse. Then we have the hypotenuse is always the opposite the right angle. So if this is your triangle, if this is the right angle, 90-degree angle, hypotenuse would always be opposite of it. That's another thing when it comes to Pythagoras theorem. This is also named after the Greek mathematician Pythagoras. So this is the Pythagoras formula, a squared plus b squared is equals to c squared. So it is not as difficult as it looks like. You just have to understand how the triangle would be identifying and labeling this. So one key insight, this theorem or the theorem lets you find any side of a right triangle if you know the other two sides. So if any other two sides is already provided to you, you'd be able to calculate the third side from it. So let's see one example with this. Here we will try to calculate for the hypotenuse. So right angle triangle has sides A which is 6 centimeters and B which is 8. You have to find the hypotenuse which is C. So we will try to see the steps first and then we will try to apply the steps to the question. First step, write the formula which is a squared plus b squared should give you c squared. That's step 1. Then you try to substitute in the values which has been provided in the question in place of a and b. So in this question, A was 6 and B is 8. So in place of A, we'll be putting 6. In place of B, substitute the 8. So it's 6 squared plus 8 squared, which should give you c squared on the other side. 6 squared is 6, which is 36. 8 squared would be 8 times 8, which is 64. So if you do 36 plus 64, you would get 100 this side, which is equals to c squared on the other side. Remember, in this question, we're just trying to calculate for the hypotenuse, which is just the c. So you'll be applying opposite operation to this. So if it is squared this side, you would be doing square root because that's the opposite. So if you do square root this side and the other side, opposite sides cancels out and square root of 100 would be equivalent to 10. So that means your c is equals to 10. So that would be the hypotenuse. So that's how you'd be solving for the unknown side. Like you can see in the diagram, if this is the 90-degree angle, directly opposite of this, you would be having the hypotenuse. The other two sides, one of it is going to be called the adjacent. And we have the opposite. So these are the other two names for the A and B. So we have adjacent side, we have the opposite, and then we have the hypotenuse. So that would be A, B, and C. So that's how this question comes to 10 centimeter for their hypotenuse. So if you are able to understand the steps, writing in the formula, then substituting in the values, then calculating, then ensuring that you're just calculating for the variable and not the one with the squared, you should be good to go. Now let's see how you'd be going about calculating for the missing side. So in this case, you can see A is provided, C is also provided. So that means they have already given you the hypotenuse. What we don't know is the B. So first of all, you'd have to rearrange the formula because currently we know that A squared plus B squared should give you C squared. This formula would apply if the C is not provided. But in our case, the C is already given, which is equivalent to 13. So that's 13 squared here. A is also given, so that is 5. B we don't know about. So we try to make our B the subject. So So you'll be applying opposite operation. You're trying to make your b the subject. So if it is 5 squared here, take it to the other side. So you'll do minus 5 squared from this side, minus 5 squared from the other side. Opposite cancels out. Now you're left with b squared, which is equals to 13 squared minus 5 squared. We're just solving for the b, so you'll be calculating these ones individually. So if it is 13 squared, that is equals to 13 times 13, which is 169 from here. 5 squared, we know that's 5 fives, which is 25. Subtracting the 2 will give you just the b squared right now. Remember, we are trying to calculate for the b. But first, you'll have to find the difference. So if you do 169 minus 25, you would get 144. This is equals to b squared. We don't want b squared, we just want the b. So you'll have to do square root here, square root there. The side on which you're doing opposite, it cancels out. So you're left with b. Square root of 144, from the calculator, you'd be able to obtain 12. So b is equivalent to 12 centimeters. So that's how they ended up getting it. So with this kind of question, if there is a missing side, you'd have to rearrange your formula first, substitute in the values, do the calculation, simplify the equation by doing opposite operation, and you would be able to obtain your answer for the missing side. So that's how to go about using the Pythagoras theorem. Right, so there's many other set of questions which we have on hand. If you'd like us to take you in depth with this type of questions, you can always get in touch with us. We'll be glad to conduct sessions with you. So thank you for attending. Goodbye.